So in our homework problem number 73 out of the AP textbook, we had a child sliding down a slide at some angle, and there was some transition so that the speed they attained or reached at the bottom of the slide is the same speed or velocity they had as they were launched horizontally off of the bottom of the slide at some height. And part A was basically figuring out if the kids started from rest and accelerated down the incline. First of all, what's the final velocity they reach at the bottom of the slide? And then if the kid had that final velocity when launched off of some height h, the question is like, how far do they travel horizontally? Or what is that horizontal displacement for part B? So in the AP textbook problem, they gave you values, but I wanted you to also try to solve this problem, solving for the final velocity and for the horizontal displacement only in variable form, where your final answers only included L for the length of the slide, theta for the angle of the slide, G, which is one of our fundamental constants, the Earth's gravitational field strength, which also is the acceleration caused by gravity, and for the second part, the variable h. So let's look first at part A, and this kind of goes back to our last unit where we're trying to figure out what causes this person to accelerate. Well, the reason that they're accelerating, and it says that we're going to assume that it's a frictionless slide, is because of the forces involved. And on the kid, we have a force of gravity pulling straight down. We have a normal force pushing back up. And if the kid is accelerating in this direction, remember on an incline, we kind of rotate our axes so the x direction is parallel to the surface, the y direction is perpendicular to the surface. If the kid is, let's say, starting from rest, so the initial velocity is 0, we're looking for the final velocity. We first need to figure out, well, what is this kid's acceleration? How much are they increasing their velocity each and every second? Well, we know that from Newton's second law, the acceleration in a particular direction is equal to the sum of the forces in that direction divided by the object's mass. So let's go back to the force diagram and look at the forces involved. Well, if we look at this, if the acceleration is in the x direction, the only force, or in this case, component of a force that's in that direction, is the x component of gravity. If the force of gravity is equal to the kid's mass times the gravitational field strength, or mg, the hypotenuse of this right triangle is mg, and the component in the x direction is the opposite side with respect to the angle. And remember that on an incline, the angle of the incline will be the same as this angle inside of our right triangle. So the opposite side, or FGX, will be equal to the force of gravity times the sine of theta, or mg times the sine of theta. So that's the only thing causing the kid to accelerate down the slide. It's the x component of gravity. So let's go back to Newton's second law. Now that we know that the acceleration in the x direction is caused only by the x component of gravity, we get the x component of gravity divided by mass will give us our acceleration of the kid on the slide. We said that the x component is equal to mg times the sine of theta. Well, for solving for the acceleration, we take that divided by m, and we see that it doesn't matter what the mass of the kid is, since we have m divided by m, that cancels out. And so the acceleration of the kid on the slide, or the acceleration of anybody, regardless of mass, will just be g times the sine of theta. So we can now use this as an expression for the kid's acceleration. Well, remember, we're trying to find out the final velocity, assuming that the kid started from rest with an initial velocity of 0 in our x direction. Remember, our x direction is in the direction down the slide. So now we're just going to find the velocity of the kid at the bottom of the slide. So now we just have a one-dimensional kinematics problem. We're looking for the final velocity. We know the initial velocity is 0. We just found an expression for the acceleration in that x direction. And this is that third equation on our AP equation sheet. It's all multiplied by the displacement in that direction. So doing some simple substitution, we're looking for the final velocity of the kid at the bottom of the slide. The initial velocity is 0. The acceleration we said is g times the sine of theta. And our displacement, if we look back at our slide, the kid is being displaced over a distance of L. So we're going to substitute L in for final minus initial position. So we get velocity squared is equal to 2g sine theta times L. So if we're going to solve for velocity, the velocity at the bottom of the slide will just be the square root of all of that. It's the square root of 2g sine theta times L. So this is an expression in variable form for the velocity the kid's going to have at the bottom of the slide, and with that transition, that will also be the velocity this kid has now, the launch velocity. So now that we know the launch velocity and some generic height h, this is just a horizontal projectile problem. So let's go up here. Remember in part B, we're trying to find the horizontal displacement. And if we're finding the horizontal displacement, or how far something travels horizontally in a projectile problem, remember, we've got to use our displacement equation. That's the second equation in our AP equation sheet. Remember that in the x direction, there is no acceleration. Horizontally, the velocity stays constant. So this whole term goes to 0. And so we basically get the horizontal displacement is equal to the horizontal velocity multiplied by the time. Well, we came up with an expression for the horizontal velocity, remember? That's back down here. It's the square root of 2g sine theta times L. So our horizontal displacement will be the square root of 2g sine theta times L, all multiplied by some expression which represents how much time this kid spends in the air. Let's go back to our horizontal projectile problem. Remember that vertically, the kid behaves like a dropped object, because if we go to the vertical direction and look at the information that we have, if we're going to solve for time, since that velocity is only horizontal, there's no part of it in the y direction, so the initial vertical velocity is 0. The acceleration in the y direction is just g, the acceleration of gravity, negative 9.81 meters per second, or negative 10 approximately. And the vertical displacement of the kid in this problem is represented by the height of the slide, or h. So if we look at our displacement equation for the vertical direction, we have the change in y position is equal to initial velocity times time. That whole term goes to 0 because the initial velocity is 0. Plus 1/2 times the acceleration in the y direction, all multiplied by time squared. So change in y is just h. The acceleration in the y direction, we can just substitute g, acceleration caused by gravity, and we get some unknown time squared. So we can just now solve this equation for t to get an expression for how much time the kid spends in the air. It's the same as any dropped object. So I'm going to multiply each side by 2, so we get 2h is equal to g times t squared. If I divide by g and then take the square root, we find out that the time is equal to the square root of 2 times the height divided by the acceleration of gravity. And this is an expression for time which only has h and g in it, 2 of our allowed variables. So now we put that expression all the way back up into our final expression for the horizontal displacement. So remember, the horizontal displacement is equal to the horizontal velocity times time. So we get our expression for the horizontal velocity all multiplied by our expression for time, and we get that the final answer for the horizontal displacement of the kid projected horizontally off of the slide from some height h is the square root of 2 times g times the sine of theta times L, all multiplied by the square root of 2 times h divided by g. And of course we could simplify this a little bit, but this is as far as you would need to go if you were to answer this question on a test. Hope this has been helpful.